In this video, we want to look at Hooke's law. Now, Hooke's law has to do with a material that is elastic. When we talk about an elastic material, we're talking about a material that has the capacity or that ability to regain its original shape, original length after undergoing its distortion when a force that produces that distortion is removed. So now Hooke's law states that the extension or compression for an elastic material is directly proportional to the force applied, provided elastic limit is not exceeded. If we want to write this mathematically, Hooke's law is saying that force is directly proportional to extension. So this thing is conditioned on the condition that elastic limit is not yet exceeded. So if we remove this, we can have that F is equal to, we put a force constant Fe. So if we are to draw this diagrammatically and we are to plot a graph of force against extension. Now force is in Newton, extension is in meters. We're going to have a graph that goes this way. So a point here means any number where it gets here. Let's say it is P, and let's say we have this, and let's say here is Y, and let's say here is B. Now the meaning of P is the proportional limit. And here, let's say here is E, and that E is elastic limit, and this place Y is called yield point. Y here is called break point or breaking point. This question says the force of 20 Newton produces an extension of 3 millimeters in a certain elastic material. How much force will be required to produce an extension of 7 millimeters? We can solve this in two ways. The first one is, since F is equal to Ke, it means that if we make K subject of the formula, K becomes F over E. Now we can find K by saying F over E. The F given to us is 20 Newton. If we call it F1, then the extension that it produced was 3 millimeters. And we will not use this in millimeter. Rather, we'll convert it to meters by dividing it with 1000. So we'll have 3 divided by 1000 is now in meters. So what it means is that our K, making K subject of the formula, is now 20 over 3 times 10 raised to the power minus 3, which will give us 6666.667. So Newton per meter. Now we can now find the second force, still using F is equal to Ke, and we will now say that our K is 6666.667 times the second, which is 7 millimeters. We'll still say 7 divided by 1000 is now in meters, and if we multiply that, we're going to have 46.67 Newton. The second way we can solve this is by saying that Hooke's law is also stated as F1 over F2 is equal to E1 over E2. Our F1 already is 20. We don't know F2. Equal to, first extension is 3 times 10 raised to the power minus 3. Second extension is 7 times 10 raised to the power minus 3. If we make F2 subject of the formula, we're going to have 20 times 7 times 10 raised to power minus 3 over 3 times 10 raised to power minus 3. This can take away this. What we now have is 20 times 7 divided by 3, and that will give us 46.67 approximately Newton. So pick the one you understand better.